Well, hi everyone. I'd like to welcome you to today's AHRQ training webinar on the Clinical Decision Support Authoring Tool. Although a few people are still logging in, we're going to go ahead and get started. My name is Ed Lomotin and I'll be moderating today's webinar. This slide shows the agenda for today. As Gerald mentioned, we are recording this webinar and the recording will be available to the Ark Health IT YouTube channel in about 2 weeks. You will be notified via email when the recording and the PowerPoint slides are available online. Again, my name is Ed Lomotin and I'm your moderator for today. I currently serve as a medical officer and Chief of Clinical Informatics in the Center for Evidence and Practice Improvement at Ark. We're pleased to have with us today two esteemed presenters, Sharon Sebastian and Chris Moesel of the MITRE Corporation from the Cbs Connect Project team. Sharon is a principal clinical informaticist at MITRE and the Cbs Connect Project lead. She has over 20 years of critical care nursing, healthcare administration, and informatics experience, most recently focused on electronic clinical quality measurement and clinical decision support. Chris is a principal software systems engineer at MITRE and the technical lead of the Cbs Connect Project. He has over 15 years of experience developing software and is a co-author of the HL7 Clinical Quality Language CQL specification. This slide shows the learning objectives for today's webinar. By the end of this presentation, we hope you'll be able to develop logic, including inclusion and exclusion statements, and define the recommended intervention. Discuss how to develop base elements that can be reused across logic statements, along with features that enable users to develop subpopulations and how to handle errors. Use synthetic test data to verify that authored CDS logic works as expected. Save and download your logic expression and provide an understanding of the components of the downloaded zip file. And understand how other systems and tools developed by the Cbs Connect project, such as the repository and Cql services, can be used to share and implement the logic developed within the authoring tool. And now let me turn things over to Sharon.
Hi, I'm Sharon Sebastian from the MITRE Corporation. I'll be providing an overview of the Cbs Connect project and a few knowledge translation resources that we use when developing decision support. So the Cbs Connect project is sponsored by the Agency for Healthcare Research and Quality to facilitate and enable the advancement of evidence into clinical practice. To achieve this, the Cbs Connect team has developed tools that make creating, sharing, integrating, and implementing standards-based decision support into health IT systems easier and more accessible to healthcare organizations. The project is in its third year of performance, and there are two primary systems within the effort that are shown in the central column of the diagram. The first is the Cbs Connect Repository, which is a web-based database, or kind of like a library, and it hosts contributed decision support logic that's publicly available and free to download and use. The second system is the Cbs authoring tool, which is what we'll be demonstrating today. The authoring tool eases the development of interoperably expressed decision support. Both of these systems are central to the Cbs community that we're fostering, which is displayed to the left and right of the systems. Anyone can be a contributor to the repository. Often contributors are government agencies who've sponsored work, along with researchers and academic institutions. As you develop CDS using the authoring tool, perhaps you can consider contributing that decision support to the repository also. On the consumer side, it's often individuals who are interested in identifying logic to support quality improvement initiatives within their organization. And the repository acts as a matchmaker of sorts to assist in that process. The project has several interwoven work streams. The first is the repository itself, which is live now and accessible via the hyperlink in the lower right-hand corner of the slide. If you click on the term artifact in the blue menu bar, you can view the CDS artifacts, or what they really are pieces of logic that are available right now. At present, there are 33 artifacts contributed by 10 different organizations, and they include a range of clinical topics. We've also created the authoring tool, which you'll learn a whole lot more about in the next few minutes. Each year, the project selects a use case to work through while developing decision support artifacts. For instance, last year the use case was supporting informed shared decision-making to manage chronic pain. And through collaboration with pain management subject matter experts and clinicians at our pilot site, we developed a pain management summary that displays all of the factors in a patient's health record that should be considered when managing pain. This year, we'll be developing patient-facing preventive health decision support to inform and support health and wellness along with patients' engagement in their health. Ultimately, everything that we develop is posted on the repository and available for others to use. We also pilot the decision support that's developed every year by partnering with a healthcare organization to implement it in their system. Throughout the integration, testing, and live implementation process, we document lessons learned and recommendations to promote a learning health system and also inform the efforts of others who are considering the use of CDF in their organization. Finally, we lead a work group discussion that occurs once a month, and it's attended by a diverse range of very generous individuals across the decision support landscape. These clinicians, engineers, vendors, subject matter experts in standards and decision support, and sponsors of CDF's work serve as a sounding board for new enhancements that we're considering so we can ensure that we develop systems and products that support the use of individuals in the organization. There we go, okay. So in the CDS world, evidence-based knowledge moves through 4 different categories or levels of expression as it's translated from narrative text to executable code in a health IT system. This graphic provides a high-level understanding of a framework cited in the lower box, where the authors describe a level 1 representation as the narrative text within a clinical practice guideline or recommendation statement. As a clinical subject matter expert interprets the guideline or recommendation statement and begins to boil down the information, they develop a level 2 or semi-structured decision support expression that includes human readable logic, and often that's formatted as a if-then statement. And that logic will actually be handy for you to have nearby as you begin to develop the structured logic in the authoring tool. The next step of the knowledge translation process is a level 3 or structured representation, and that's where the authoring tool comes in. The authoring tool enables individuals to use HL7 standards like FHIR resources and the clinical quality language, or CQL, to develop a structured version of the knowledge. And then a level 4 expression includes additional code that makes the standards-based code executable in a local system. So I know that there's a lot going on in this diagram, and it's probably really hard to read, which is why I've included the reference in the slide. But I've included it for your awareness and as a resource for those who may be translating guidelines into computable decision support for the first time. The diagram depicts the activities that a multidisciplinary team performed during decision support development. And there are 3 groups of activities that parallel the translation framework that I just cited in the last slide. The first group of activities support the selection of an evidence-based source from which the decision support logic will be derived. It includes doing an environmental scan of all the guidelines that are available in a clinical topic and understanding where they align and diverge so you can make a conscious decision on what exactly you're going to express. Then you begin to mark up the narrative text to highlight data that's going to be needed by the logic. This is actually a good point to pause and determine if development of that decision support concept is going to be feasible based on data availability and accuracy. The second group of activities focuses on disambiguating the narrative text and filling in gaps, such as exclusions, to ensure patient safety. This work will enable the development of first the human readable logic and then soon thereafter the structured code. And the last group of activities facilitates integration of the coded logic into an EHR or health IT system. It includes things like data mapping and identifying triggers and actions to make the CDF executable in a local health IT system. So now I'll pass the presentation over to my colleague Chris Moesel, who's also from MITRE, and he's going to discuss decision support authoring tool standards.
Good afternoon and good morning. As Sharon noted, my name is Chris Moesel, and I'm the technical lead for the Cbs Connect project. Now, before we jump into the demonstration, I do want to talk a bit about standards, because at the Cbs Connect project, we're all about interoperability, and we build interoperability on top of standards. We need common ways to talk about certain things, common ways to describe what data looks like, and common ways to determine how we can actually exchange that data between different systems over a network or what have you. So for this reason, the CDS authoring tool is really anchored in standards. And the standards that we've chosen for the authoring tool are the HL7 Clinical Quality Language, or CQL, and the HL7 FHIR standard. The HL7 CQL language is really a high-level language for describing the clinical logic that you would use when expressing clinical decision support rules or electronic clinical quality measures. It's actually built up into two distinct modules. The first one is really what we normally think about when we talk about CQL. This is that author-friendly language for describing the logic. It's something that you can look at and you can get an idea of what's going on with the logic, and you can review it. It's really built for normal people, or at least semi-normal people who enjoy looking at things like standards-based logic. The second component of CQL is what we call the Expression Logical Model, or ELM, or ELM. And what that is that's a representation of that same logic, but it's represented in a more computer-friendly format. So it's represented using XML or a standard called JSON. So we have tooling that's available that can take that very author-friendly language, can translate it into that language that the computers would be able to process more easily, and that's called ELM. The CDS authoring tool actually produces both the author-friendly CQL language and the expression logical model language for processing. Now, CQL, when it was built around existing best practices and lessons learned from previous standards around electronic clinical quality measurement and clinical decision support, as well as leveraging the expertise of HL7 work groups like the Clinical Decision Support Work Group and the Electronic Clinical Quality Improvement Work Group. CQL is actually designed to work with any data model. So CQL really describes the ways that you can manipulate data and calculate on data, but the shape of that data, or the data model, can actually be determined at authoring time. This allows CQL to actually live beyond the popularity of any particular data model, so that right now FHIR is all the rage, but if in 5 years there's something else, CQL isn't irrelevant because it's not anchored on a specific data model. It can also work with other ones. But right now, as I mentioned, FHIR is the language du jour for data models. So this is a CQL example. This shows how you could query for a patient's most recent systolic blood pressure value. And I'm not asking you to necessarily understand this, but it gives you an idea of what a query might look like in CQL. This is actually probably more complex than it actually needs to be, but it's a good example showing some of the features of a CQL query. So in a given CQL library, oftentimes we will build up multiple queries like this to get the data that we want. We give them names, like in this case, last systolic BP value. And then we can, oops, I hit the wrong button. Okay, I apologize. The end button is right next to the page down button. All right, there we go. Then we can take those individual expressions that we built up using queries, and we can bundle them together to create higher level expressions. So this is also CQL logic that you see here. And this is showing higher level expressions that define things like whether a patient is an Indian demographic, or whether a patient has certain CVD risk factors, and finally if they meet some inclusion criteria for, say, a clinical decision support rule or electronic clinical quality measure. So those are kind of the nuts and bolts of CQL. So now FHIR. So many of you have probably heard of FHIR. FHIR is an extremely popular standard right now. I'd say that most of the major vendors are working on it or already have versions of it published. And essentially, FHIR has two main components to it. One is that it describes what the data should be formatted like. So when we're talking about, say, a medication order, or we're talking about a problem on a problem list, FHIR actually describes how would you represent that data in a standardized way. It also describes how you can exchange that data. So now that we have the representation, how is that data actually sent back and forth over a network between systems for interoperability? These are examples of FHIR resources. On the left-hand side, we have a very simple patient resource for a patient named Brenda Jackson. I will note that this is synthetic data. It does not pertain to any real Brenda Jackson. But we can just see here that she's a female. She was born in 1956. On the right-hand side, we have an example of what a problem might look like on a problem list. It uses the FHIR resource type called condition. And this specific problem is fibromyalgia. So that gives you an idea of what the data looks like that would be fed into the clinical decision support logic that is expressed using CQL. So that's it for the slides. Now we're going to jump to the live demo. So I'm going to share my screen. Great. And right now, we are looking at the cds.ahrq.gov website. So that's cds.ark.gov. This landing page actually shows several of the CDS-related efforts that Ark is involved with. And it provides lots of great information, and clicking through to other sites, I'd recommend that you do check it out at some time. But for this webinar, we're really focused on CDS Connect. So I'm going to go to CDS Connect in this menu here and click on that. This brings us to the CDS Connect portion of the website. You can see in the blue bar that we have some navigational aids. This allows us to find out more information about the CDS Connect project, about the way that we govern our artifacts, about our community efforts like the work groups. It provides a link to the authoring tool, and probably the primary feature of the CDS Connect repository is the repository itself, which we can get to by clicking on Artifacts. So now that I've clicked on Artifacts, I can actually see a listing of all the CDS artifacts that are currently hosted in CDS Connect. At the top, we have a section for new artifacts, but then below that, they're organized by topic. So you can see there's a variety of topics, as well as a variety of organizations that have actually published CDS for these artifacts. Each one of these artifacts is free to review and download as you see fit, and to even integrate into your systems. They're based on standards. They're not all based on CQL, but CQL is a target standard for many of them. So we're actually going to click on one of these artifacts, the statin use for the primary prevention of CVD in adults. This is an artifact that we developed during the first year of the CDS Connect project. It's based on the United States Preventative Services Task Force recommendation for prescribing statins. You can see here, looking at the page, there's a lot of metadata about the artifact itself. There are also links to some important reports. So these are things like the pilot report, which gives us information about how the pilot was actually implemented and what were the results of the pilot, so you can get an idea of how this worked in the real world when we actually put it to the test, as well as some of the artifact enhancements based on the pilot. There are other documents linked in here that talk about the decision-making processes that we went through as we were developing this artifact. But I'm going to actually scroll down toward the bottom to the level 2 representation of the artifact. So if you recall from Sharon's presentation, artifacts actually go through 4 different levels of representation. Level 2 is the semi-structured representation. So this typically might be a bulleted list. It's usually something that's very easy to read, and it gives you a good overview of the general logic of the artifact. So for this particular artifact, I'll go ahead and increase my font a bit. We can see that there are a set of inclusions. So these describe what type of patient is eligible for this recommendation. And we can see right here that the first inclusion is age criteria. The patient must be between 40 and 75 years of age. And then we're looking for 1 or more risk factors. Risk factors are things like an LDL result that's above 130 or HDL below 40. There's several things here that are considered a risk factor. And then finally, we're looking at the 10-year CVD risk score. And we're looking for that to be greater than or equal to 7.5%. Now below the inclusions, we also have exclusions. So there are some cases where perhaps a patient meets the inclusion criteria. They normally would receive this recommendation, but for one reason or another, we don't want to provide the recommendation because of something else going on. In this case, because this is a recommendation for primary prevention, if they already have CVD, then it doesn't really apply. Another one here at the bottom is if they're already receiving a statin, then we don't need to provide another recommendation to receive a statin. So those are the exclusions. And then below that, we have the interventions and actions. And the top 2 here are really the recommendations pertaining to this particular artifact. The first is that if their CVD risk score is between 7.5% and up to 10%, then we want to discuss initiation of a low to moderate intensity lipid lowering therapy. That's a grade C recommendation, which is why it's discussion. It's just, consider this. The next recommendation would be if the CVD risk score is greater than or equal to 10%. That's actually a grade B recommendation, which is a bit stronger and really does encourage that a statin should be started based on some conversation with the patient. But that's certainly stronger than the grade C recommendation. Now the last part I want to show you on this page is at the bottom we have logic files. So these are zipped up files that you can click on and download. And if you unzip them, they actually contain the standards-based CDS logic for the artifact. So this will bring us the CQL files, the ELM files, that you could then integrate into a CQL-aware health IT product. But of course, most of you, I think, are here not to learn necessarily how to get CDS that's already been developed, but how to create your own CDS. So now we're going to talk about how we would actually go through the process of creating CDS that looks like the CDS that we just reviewed here. So I'm going to go back up to the top of the page. I'm going to click on Authoring Tool. This brings me to a page that provides some information about the authoring tool, but really I want to go to the CDS authoring tool. So I'll click the Go to the CDS authoring tool link. And that brings us up to the main page of the CDS authoring tool. So you can see here that there is, again, a menu bar at the top, and there is a big sign up button in the middle. So the CDS authoring tool does require that you have an account. The reason we need that is because you'll be developing your own artifacts, which we'll be storing in a database, and we need a way to associate those artifacts to you so that when you come back to the tool in a week, we still know which artifacts are yours. In order to do that, we need an account. So if you click on the Sign Up button, that brings you to a form where you fill it out. We're just asking for your full name and your email, and then you can submit that form. We'll receive that, we'll create you an account, and we'll provide you information about how you can access that account and use it with the CDS authoring tool. So I already have an account, so I'm going to click on the Login button. This provides the login dialog, so I'm going to type in my credentials. And log in. All right. So now we're still on the landing page, but we can see my name is up here showing that I'm logged in. And we can see that the sign up button went away and we have a get started button instead. Well, I'm going to jump right to the artifacts listing. This shows all of the artifacts that I am currently working on. And it allows me to go in to view them, to export them, or to edit them as I see fit. This is my own sandbox. Only I can see this, nobody else. It's not shared. So really I can work on this artifact and I can do whatever I want with it. If I'm a commercial company, I can use it to integrate into my own product. If I want to share with others, then I can create an artifact and then I can share it on the Cbs Connect repository. That is up to you. Of course, we encourage sharing, but really we don't force it. And so it's important to know that anything you do in this tool is visible only to you. So we're going to create a new artifact based on the one that we were just looking at. We're going to call it Statin Use Demo. We're going to give it a version 1. And I do want to just note that we're not going to represent the entire CDS artifact as we just saw it, because that would take a lot longer, but we'll do some of the main components. So I'm going to click on the Statin Use Demo artifact that I just created, and that brings us to our workspace, or our builder page. You can see here that we have a number of tabs here that represent different components of the CDS artifact. Right now, the CDS authoring tool is primarily focused on rules-based CDS. So this is CDS that typically is going to describe a certain criteria to check on a patient and then provide recommendations based on that criteria. It is possible to use the authoring tool to help develop logic for other types of CDS as well, but so far that hasn't been our primary use case. So we're actually going to go through these tabs one at a time as we build up the logic. So the first tab that we're looking at here is the Inclusions tab. This is where we build up the criteria that is going to determine the different factors that must be present in a patient's record in order for them to be considered for this recommendation. So these are all the things that we want to be present or to happen in order to recommend a statin in this case. If you may recall, when we were looking at the artifact in the Cbs Connect repository, the first criteria was an age range. So that's what we're going to build first. Now, whenever you build elements for criteria in Inclusions or Exclusions or the other tabs, you typically have an element chooser. I'm going to click on that. And this gives us a number of different element categories that we can use as we build up the criteria. The first thing we're going to do is the age range, so that is considered demographics. So I'm going to click on that. I get a second drop down here, and I'm going to choose age range. Now, whenever we build an element in Cbs Connect authoring tool, we're typically presented with a form to fill out information about the details of that criteria. So in this case, we have a form for age range. We'll see other types of forms as we continue authoring. Now for each one of these, we generally want to give it a name. So for this one, I'm just going to name it what it is, age 40 to 75. Okay? And we're actually going to fill out that information in the form now. We're going to make a minimum age of 40, a maximum age of 75, and last we need to pick a unit of time. Now this actually supports all of the different units of time that CQL supports. So we're going to use years but for pediatric cases and things like that, there are also smaller units. But here we can see that we've built up our first criteria. Now for each of these elements, we generally try to provide a auto-generated summary of what the element is saying as well. So for this case, we can look at the auto-generated summary here, and we see that it says the patient's age is between 40 years and 75 years. So there we have it, our first criteria. If that was all we cared about, then we could actually stop the inclusions right here. But that wouldn't be very interesting, so we're going to continue going. I'm actually going to go ahead and minimize this. And I'm going to say, okay, that first criteria is great, but I want more, so I'm going to say, and something else. Now, one of those risk factors that we saw in the artifact was based on the LDL value. It was looking for an LDL that is greater than 130 milligrams per deciliter. So that's what we're going to build up next, because it's actually a nice, interesting sort of component to build in the authoring tool. So I'll click on my element chooser again, and I'm going to go to observation. Now, if you're familiar with FHIR, some of these may look very familiar to you because these are generally based on FHIR resource names. And LDL, which is a laboratory test, is typically represented in FHIR as an observation, which is why we're choosing this. Now that's great. That gives us observation, but we do need to narrow this down. We're specifically interested in LDL observations. So the way we typically do that in standards-based clinical decision support and electronic clinical quality measurement is through the use of value sets. If you're not familiar with what a value set is, you can think of it as a grouping of clinical codes for a specific purpose. So in this case, we want a group of codes that represents all of the codes that might be used to represent an LDL test in a patient's record. So essentially, it's just a big grab bag of synonyms or grab bag of codes that are related to each other. There are other uses of value sets as well, but that's primarily what we're looking for here. Now, the National Library for Medicine provides a great service called the Value Set Authority Center. And this is a service that allows people to create and share value sets. Okay? So the CDS authoring tool is integrated with the Value Set Authority Center so that we can use it as our primary source for value sets. Now the Value Set Authority Center also requires an account. This is a different account than the CDS authoring tool account. And you need to ask for this account from the National Library for Medicine. If you Google for the National Library of Medicine or if you look specifically for UMLS here, you should be able to find a link to create your own UMLS account that you would then be able to use here. So I'm going to type in my account with NLM and UMLS. I'm going to click on Login. Once I do that, I can see that I logged in effectively because I now have two new buttons, an Add Value Set button and an Add Code button. In this case, as I described, we're really looking to add a value set. So I'm going to click Add Value Set, and this brings up a search dialog. Now we are looking for LDL-based value sets, so I'm going to do a search for LDL. And that provides me a set of results. As you can see, there are actually several LDL value sets with varying numbers of codes. So one of the things is that as you're building up standards-based CDS, there is some legwork involved to determine what are the best value sets available to you and what's going to work out best here. So we've already done that legwork ahead of time. So by the time I get here in the CDS authoring tool, usually I already know which value set I'm interested in. And in this case, we know that it's the NCQA value set here that has an identifier that ends in 1029. So I'm going to click on that one. And what it does is it will actually reach out to the Value Set Authority Center again using one of their FHIR-based APIs to get all of the codes that are a part of that value set so that I can review this and just confirm that, yes, this is in fact the value set I'm interested in. So here you can see these are all of the LOINC codes that might be in a patient's record to represent an LDL reading. So I'm going to select that. And that brings us back to our element builder. Now, what we've described right now is just observations with the code from the LDL test value set. You can see a little error here that says element must have return type Boolean. So what does that mean? That means that at the end of the day, this element thing that we're describing needs to end with a true false value, or it needs to end with a yes or no answer. Again, what we're doing here is we're trying to describe criteria that a patient should meet to receive the recommendation. So for each of these, we need to get either a yes back that says, yep, this qualifies them, or a no back, nope, doesn't. So until we actually have data that will return that type of answer, we're going to see this little warning here. So the way that we can actually further manipulate the data that we have to get to the answer we're looking for is by adding expressions. I'm going to click on Add Expression. And here you can see that I have a number of options available to me that I can apply to this current element. The first thing I'm going to apply is verified. So that's just saying, you know, we really only want those lab tests that have been signed off on, that have been verified. But then we also really want to look at just the most recent one. So instead of giving me all of those LDL tests, just give me the most recent verified observation with a code from LDL test. Now we're getting closer to what we're looking for, but we're really interested in the value of that test or the result. So I'm going to click on the quantity value expression. And then last, we want to do a comparison on that. So I'm going to choose value comparison. And this gives us a few form fields where we can say, well, we're really looking for an LDL that is greater than 130. And then over here, we can enter in our units. We're interested in milligrams per deciliter. Now you can see as I'm typing here, I have this nice little drop down that is giving me examples of valid units that I could use. This is another capability that's actually provided by the National Library for Medicine that we were able to integrate into the tool. It's really cool, and we're glad that NLM does great things like this. So if you're from NLM and you're on the call, thank you. So we've actually just completed this element. We now have an element that represents the criteria that there must exist a most recent verified observation with a code from the LDL test value set whose value is greater than 130 milligrams per deciliter. So now we have our first two inclusion criteria. We're going to do one more inclusion criteria to demonstrate the concept of what we call base elements. Now, base elements are used whenever you want to describe an element that will be used in multiple portions of the CDS. In this case, we're interested in the CVD risk score, but we know we're going to use that CVD risk score in multiple places. So we actually want to define it as a base element, something that we can base other things on. So when I click on the Base Elements tab, I'm presented with this very familiar element chooser. And this is very much like the process we just went through. I can choose an observation. And now instead of adding a value set, I'm actually going to choose a specific code. That's because for this CDS, what we're expecting is that there is a CVD risk score already stored in the EHR, and that it's stored using a specific standardized code. So when I click on Add Code, this gives me a dialog where I can actually enter the code that I'm looking for. This is another case where I've done my homework. I already know the code that I'm looking for. Here, I actually have to type in the code by its number. Its number is 79423-0, and it's a LOINC code. Now, perhaps in future versions, we may be able to incorporate a capability to be able to search and find these types of codes. But right now, you do kind of need to know what the code is. But we do allow you to validate it, which will reach out to the NLM again and actually say, hey, what is this code? And here we can see that it is the cardiovascular disease 10-year risk likelihood code. So I know I have the right one. So I'm going to go ahead and select that. I'm actually going to give this a slightly more interesting name. I'm going to call it the 10-year CVD risk. And again, I want to add some expressions here because what I'm really interested in is, first of all, I want it to be verified. I want it to be the most recent one. And really, we're always going to be talking about its actual value. So I'm going to choose the quantity value. So now I have a reusable expression that I developed in my base elements. So we'll go back to our inclusions. We're going to scroll down. Now I'm noticing here, actually, I'm going to rename this just to be LDL greater than 130 milligrams per deciliter, so that when we look at this later, we remember what that actually represents. But now going back to adding this third element, I can go ahead, go to base elements, and now the element that I just created, the 10-year CVD risk is available. When I click on that, I actually get a thing that looks like what we just built, but I can add further expressions on top of it to narrow it down to what we're looking for. So for the inclusion criteria, we really want to do a value comparison. We want to say that this should be greater than or equal to 7.5%. So 10-year risk score or risk likelihood of 7.5%. I'm going to update the name here to say that. And now we've just built our third inclusion criteria. That's all the inclusion criteria we're going to do today. But building other criteria looks very much like this. Now we're going to go to exclusions. So what are some of the reasons that we might exclude a patient from receiving the recommendation, even if they actually meet the inclusion criteria? The most obvious one here is if they already are ordered a statin, then we don't need to recommend that you order another one. So we'll do that one together. This one is actually pretty quick and easy. We're going to do it based on medication order. And again, we're going to look for a value set. In this case, I'm going to search for statin. And here we've received our results. You can see here that some of these actually are stewarded by MITRE. That's my organization. And in fact, we built up these value sets specifically for this artifact. Now I'm going to select the moderate intensity statin therapy. Again, it gives me the option to review the codes and ensure, yep, this is really the one that I wanted. Now, typically for this particular element, I would actually apply additional value sets. There's also a low intensity value set and a high intensity value set. The authoring tool would allow me to apply all of them at the same time. But for the purposes of this demo, we'll just stick with moderate because it's not that exciting to watch me add a whole bunch of value sets. Now, this returns back essentially all of the medication orders for statin therapy in the patient's record. Now, that could actually be an empty result, or it could be a result of 10 things. We don't know. But what we're interested here for the purpose of the exclusion is we want to look at the active ones, and we just want to verify that one exists. So we're basically saying that if there exists an active medication order with a code from the moderate intensity statin therapy value set, this patient should be excluded. I'm actually going to change this name to on statin therapy. Again, these names just help us to get an idea of what this is about. They're also used in the exported CQL to name the expressions. So now we've built up our inclusion and our exclusion criteria. If we just wanted to provide a single recommendation, this might be all we need, because now we've defined the patients who should receive the recommendation. This particular artifact, however, has two recommendations. One recommendation that applies to patients who have a CVD risk score of 10% or greater, and then a different recommendation that applies if it's between 7.5% and 10%. So the way that we actually then take those patients who will receive a recommendation and determine which one is by breaking them up into subpopulations. So I'm going to click on the subpopulation tab. And Our first subpopulation is going to be, CVD greater than or equal to 10%. We're going to, again, go back to our base element for the 10-year CVD risk. Okay, and we're going to add this expression, value comparison, and we're looking for it to be that greater than or equal to 10%. Now, this name is actually already in use, so I need to give it a different name. So we'll just call it 10-year CVD risk, greater than or equal to 10%. And this is our first subpopulation. So this represents all of the patients who meet the inclusions, aren't excluded, and have a CVD greater than or equal to 10%. Now we'll create a second subpopulation that represents the rest of them, and that's going to be CVD greater than or equal to 7.5% and less than 10%. Again, this should be looking pretty familiar. We're going to choose a base element, 10-year CVD risk. We're going to do a value comparison, and we're going to say greater than or equal to 7.5% and less than 10%. Again, we need to give this a slightly different name, so greater than or equal to 7.5% and less than 10%. Great. So now we have our two subpopulations. We can use those now to provide different recommendations, which is what we'll do next. So we'll click on the Recommendations tab. This is where we can actually type in what are the recommendations that we want to apply. So first, we're going to associate the recommendation with one of our subpopulations, the CVD greater than or equal to 10%. And our recommendation is just going to be start a low to moderate lipid lowering therapy, which I think is just fancy speak for statin. And that is a grade B recommendation. Now this is just text here. When we integrate this into a system may choose to just take the text and show it on the screen, and that's fine. Or they may choose to integrate at a more discrete level, where they're actually going to be looking at the logic and looking at the flag that indicates whether or not the grade B recommendation should be applied. So that's our first recommendation. We're going to create one more. And for the second recommendation, we are going to associate it to those who have a CVD risk between 7.5% and 10%. And this one is going to be discuss a low to moderate lipid lowering therapy. That's a grade C recommendation. Great. So we have just defined all of our criteria, our subpopulations. We've associated it to recommendations. This artifact actually could be done now, but we did promise that we would show how to handle errors as well. So I want to do that next. You'll see here we have a Handle Errors tab. This allows us to, based on different criteria, return an error message. In our case, for this recommendation, we're actually going to choose to return an error message if a patient is excluded. So here we'll say, if they meet the exclusion criteria, we just want to provide a friendly message that indicates why they're not receiving the recommendation. So here we'll say, recommendation, we'll spell it correctly, recommendation not provided because the patient was excluded. This way, if that happens, it'll be obvious why the recommendation isn't there. This might not be how you want to design your CDS artifact, and that's fine, but I did want to show you how something like this could be done. So at this point, we have a recommendation, or an artifact, I should say, that can return two recommendations, a grade B recommendation and a grade C recommendation. Now, one of the things that we encountered when we were piloting this artifact is that some organizations might have policies that say, we don't want any grade C recommendations. We don't allow them. Well, this artifact, as we wrote it right now, would violate that policy because it might return a grade C recommendation. Now, if we want to support organizations that do allow it and organizations that don't, we need a way to be able to configure this CDS artifact. And the way you do that in CQL is by defining parameters. So I'm going to click on the Parameters tab here. I'm going to create a new parameter. What we want to create is a parameter that allows the organization to indicate whether or not to allow the grade C recommendation. So I'm going to say allow grade C is going to be my parameter name. These are all of the parameter types that we could choose. In this case, this is a simple flag, a true, false value. So again, that's a Boolean. So we're going to pick Boolean. And we're going to go ahead and choose a default value of true. So by default, we're going to return the grade C. But if somebody wants to override that, they could pass in a parameter called allow grade C, set it to false, and then this logic would actually not ever return the grade C recommendation. Now, of course, we need to actually integrate this parameter into the logic somewhere. The best place to do that would actually be into the subpopulation that is used for the grade C recommendation. So here is our subpopulation that's for 7.5 to 10%. What we're going to do is we're going to add one more criteria, and we're going to say, only activate this subpopulation if the parameter called allow grade C is set. So now we have just done that second criteria. We've integrated the parameter. And now if we went to an organization that didn't allow grade C, there's a way that they could actually still use this artifact and yet follow their policy for not allowing grade C. So that is basically our artifact that we just built. That's all we're going to build for this particular artifact. At this point, I could save it, and I could download it. So when I click on the Download CQL, I get two options. I can choose to download it using the FIRE DSTU2 format or using the FIRE STU3 format. So these are two different versions of FIRE. The CQL will look a little bit different depending on which one you choose. Most vendors right now support DSTU2, so I am going to go ahead and choose the FIRE DSTU2 format. We can see that that downloaded a file down here. I'm going to go ahead and click on this file. And here is our zip file, which we unzipped. And you can see here, actually, let me make it a little bigger so you can see it. There's a listing of files here. Now, these are all the files that are needed for the standards-based representation of the artifact we just built. Some of these are helper libraries that the CDS authoring tool always uses. But the one library that is most specific to what we just built is called Statin Use Demo. You can see here there is a CQL representation, which is that author-friendly logic, as well as a JSON representation, which is the more computable version. When I click on this, I can actually see that we have our standards-based CQL. This was all generated from what we just built together. So together, by filling out those forms, we were able to generate this CQL logic, which corresponds to the exact criteria we set up, which you could integrate into a CQL-aware system, and it would work. But maybe you don't want to take my word for that, or maybe we should do a little testing first. That's usually a recommended approach. So what I'm going to do now is I'm going to show you the testing capability of the CDS authoring tool. So if I click on testing here, I get into a testing interface. This allows me to provide my own FIRE-based patients to do testing on. These should always be synthetic patients. Never actually populate this with real data, please. Always use synthetic patients. If you need help coming up with synthetic patients, there is an excellent project called Cynthia. That's Synthea, Cynthia, that can actually generate synthetic FHIR patients for you. And I like to use that as a basis for building up the patients that I use to test CDS. So in this case, I'm going to bring up my patients here. Let me close this. On the right-hand side, we have my File Explorer. And what I'm going to do is take my first patient called High CVD Risk Henry, and I'm going to drag it into this Dropbox. And that is how I upload it to the CDS authoring tool. I'm going to do the same for normal Norma. And then last, I'm going to do Statin Stuart. Now, these are uploaded. If I actually wanted to see the data that is in each of these patients, I can click on the eyeball here, and that gives me a preview of the patient. So here's High CVD Risk Henry, a 44-year-old male. I can click on his conditions and see the conditions that he currently suffers from. I can also click on the observations and verify what the most recent LDL is, as well as the CVD risk score. Now there are quite a few observations here. I'm going to scroll down towards the end to get the most recent ones. And right here we can see that there is an LDL record of 136. Actually, it's a very, very precise LDL reading there, but it is 136, which we know is more than the 130 threshold that we just set up. And then we can also see that there is a cardiovascular disease 10-year risk of 15.5%, which is also above the threshold we set up. So we would expect that if we were to execute the CQL that we just created against this patient, that a recommendation should be provided. So what we'll do is we'll click on the Execute CQL button. This shows us the patient we're executing it on. We can select the statin use demo artifact that we just built, and we're going to click on Execute CQL. So what this is doing is it actually reaches out again to the NLM to pull down the value sets that are necessary to execute the CQL. And then it will actually use an open source CQL execution engine that's written in JavaScript to run the CQL inside of your browser and report back the results. So sure enough, High CVD Risk Henry did meet the inclusion criteria, did not meet the exclusion criteria, and received a recommendation to start a low to moderate lipid lowering therapy, the grade B recommendation. So that worked exactly as I expected, which is good. Demos don't always work out that way. So let's also look at normal Norma. So normal Norma is perfectly healthy. So we would expect that when we run the statin use demo against her, that she does not receive a recommendation. And sure enough, she didn't meet the inclusion or the exclusion criteria, and therefore did not receive a recommendation. Now last, to show another potential outcome, we'll look at Statin Stuart. Now Statin Stuart is exactly the same as High CVD Risk Henry, except that he is currently prescribed a statin. So when we execute the CQL on Statin Stuart, we actually see that he did meet the inclusion criteria, but he also met the exclusion criteria. So he was excluded, he did not receive a recommendation, and then we can also see that error message that we provided, which said the recommendation was not provided because the patient was excluded. So we just built up a CDS artifact from scratch. We're able to export it as CQL, and we're able to test it against synthetic patients to determine that the logic was working as expected. Now at this point, some of you may be wondering, okay, how do we actually integrate this into a system if we want to? Well, there are several approaches. Vendors are working on support for CQL. This is especially true because CQL is actually the language that is being used to describe the electronic clinical quality measures for the 2019 reporting in CMS quality programs. So many vendors are implementing it in order to support that, but vendors are also interested in implementing it for CDS like we're talking about here today. That said, your vendor might not have CQL off the shelf today, so there are other approaches as well. And I'd like to show you the Ark Cdf Github page. This is on GitHub at github.com/AHRQ-CDS. And this shows some of the open source initiatives that are a part of the Cbs Connect project. Now the Cbs Connect authoring tool that we just showed is actually available as open source. So you're free to use the Ark hosted version that we just used for the demonstration. But if you actually wanted to host the CBS authoring tool within your own organization and maintain it yourself and all the things that go along with that, you certainly could by actually getting the open source version from GitHub and building it and running it in your own organization. Now there's also a Cvs Connect pain management summary. This is a Smart on Fire application that we developed last year. And it's really interesting because it demonstrates how you can take CQL-based clinical decision support and integrate it into a Smart on Fire application. So if you're not familiar with Smart on Fire, it's kind of like a plug-in framework for EHRs that allow you to launch third-party applications from the EHR, but those applications can actually reach back to the EHR for patient data in order to populate their user interface. So if you wanted to see how you might integrate CQL-based CDS into a Smart on Fire application, you might look at the CDS Connect Pain Management Summary. The last thing that I'll show you is the CDS Connect Cql Services. So this is a project that allows you to expose CQL-based CDS through a web-based API. So APIs are ways that services can talk to each other behind the scenes. There's one very popular API that is being developed right now called CDS hooks. So if you're involved in the standard space with CDS, you may have heard of this before. It's based on FHIR, and it essentially provides a very simple mechanism for an EHR to interact with an external CDS service to get back recommendations and other results. This diagram kind of shows how it works, but the idea is that there's a certain trigger that happens in the EHR which invokes the CDS service, and the CDS service returns back what they call cards. And each card might be a suggestion or a recommendation for what should happen. So the CQL Services project that we built provides a simple way to take CQL and expose it using this CDS hooks interface so that it can be integrated with any CDS hooks capable EHR. So I'll just very briefly show that to you. This gets a little bit more nerdy, shall we say, because we're going to start looking at some code, but I'll try to make it as painless as possible. So let's bring back the CQL that we just downloaded from the authoring tool. There it is. On the left-hand side, we can see the basic structure of the CQL Services application that I downloaded from GitHub for free. And on the right-hand side, we see that CDS that we downloaded, the CQL-based CDS. First thing we need to do to integrate this with CQL Services is take all of these files and copy them into the local repository folder. That essentially registers them so that CQL Services can see them. The second thing we need to do for CDS hook support is just do some basic configuration. So this allows us to describe some of the metadata that CDS hooks requires, like an ID and a hook name. It also allows us to configure what are those cards or recommendations that should be returned. And what I'll do here is I'm going to open up our CQL on the right-hand side and look at our statin use demo configuration on the left-hand side. And I just want to show you that what we're saying is for the cards, we want to show a card based on this condition expression in population. So what that means is in the CQL, look for the in population expression, which is right here. And if that expression evaluates to true, then a card should be shown. If that expression wasn't true, then a card would not be shown. And what this expression represents is just if the patient meets the inclusion criteria but is not excluded. Within the card description itself, we've also said that we want to show the recommendation. So this right here indicates that take the expression recommendation and just display the text as it is in the card. And down here we describe, this is the actual CQL library that this is based on. That's all the configuration that we've done. So now I'm going to go ahead and start this CQL service. And for the last part of the demonstration, we're going to go to the CDS hooks sandbox. This essentially allows us to simulate an EHR environment. It's based on the CDS hook standard, so we can take any CDS hook, we can test it, and if it works in here, then we have a reasonable probability that it will work in another EHR that supports CDS hooks. So it's a great way to be able to test these hooks. The first thing we need to do is actually register the service that we just created and configured. So I'm going to say add CDS service, and I'm going to type in the URL where I'm actually hosting that service. I'm going to save that. Now to just demonstrate that we actually have it, I'm going to click on Configure CDS Services. We can see down here our statin use demo. That's what we just set up. So it is actually configured and enabled. And here I can actually select that service to see what the result is. When I select it, on the left-hand side, we see we did not receive any additional cards. We still have just the default card. On the right-hand side, we can see in the debug information that no card was provided. That's because this particular patient, Daniel X. Adams, doesn't meet the inclusion criteria. So he shouldn't receive the card. He shouldn't receive a recommendation. But if we change the patient to a different patient that I know actually does trigger the CDS, called CDS Demo LDL, we save that. That brings up Leslie Danielle Landers, whose initials just happen to be LDL. What a coincidence. And we can see here that we have received a card, a statin use demo card, and it says start a low to moderate lipid lowering therapy grade B. So we just demonstrated that the CDS that we built together through the authoring tool was able to be exported as CQL, integrated into our open source CQL Services application, and then tested using the standards-based CDS hook sandbox to demonstrate that it could actually be integrated with any CDS hooks capable EHR. So that is actually the end of the demo portion here. I'm going to stop sharing, and we'll go back to the slides here. There's some contact information here for how you can reach out to Sharon, who did the portion of this presentation before me, as well as myself, if you have any questions. And now is also the time when we do want to open it up for questions. So Ed, I'd ask you if you have any particular questions that have come up that you would like to start with.
Sure. Thanks, Chris and Sharon. This is Ed. Thanks very much for an amazing demo. We did get lots of questions, and so we're going to move on to the question and answer part of our webinar today. One thing quickly to note, if we don't get to all the questions that were submitted to the WebEx portal, rest assured we will answer them all in writing and send the answers out to all attendees. So don't worry if we are unable to get to your question. We did get a lot of questions actually, and I'm going to try to go in order that we received them in general. You also will find that if you navigated the Q&A portion of the portal, that some questions were answered if you could answer them relatively quickly. Others I had asked for a little bit of clarification to help me pose a question to Sharon or Chris. Actually, the first couple of questions that came in, maybe I'll take, and maybe it'll give you, Chris, a bit of a breather. And it had to do with how this work works with other work that might be similar. I wasn't sure exactly what that question was referring to, but as I just want to repeat or reinforce, I guess. At the beginning, Chris had mentioned, or Sharon had mentioned, the CDS Connect project is one of several components of what Ark is doing around CDS currently. There's a learning network, a patient-centered CDS learning network that's led by RTI. It's a cooperative agreement. It's meant to be a nexus for stakeholder engagement for this CDS work. We also have funding announcements for grants for decision support. And I'd encourage you to go back to the landing page, cds.ark.gov, to learn about each of those other components. If this is more around, if you're an Ark grantee or even not an Ark grantee and you're really interested in potentially contributing decision support to the CDS Connect repository, you've developed CDS as part of a research project, I'd encourage you to please reach out to us through the CDS Connect site, and we can talk with you directly about how you might contribute content to the repository. There was another question around whether we'll have FHIR resources available, and it was coupled with a question around the Davinci Project. And to be clear, I'm not part of the Davinci Project, but we are involved with it to some degree. So for those of you who don't know, the Davinci Project is a project within HL7 that's focused on how payers and providers can exchange data for specific use cases such as coverage requirements, discovery, and documentation templates for coverage rules. It's interesting, so CMS is actually using the CDS Connect repository, specifically its API, as a reference implementation for one of the Davinci use cases. And actually, one of the things that Chris showed briefly on there was our GitHub site. There is actually an open source, the API for our repository is open source, and that's what CMS is using for one of its reference implementations. And actually, you can navigate, I don't know, Chris, if you are able to do this, but if you can show folks how you might get to those, how to get to the GitHub site through CDS Connect. It's for folks who started on CDS Connect site, you have to go to the Community tab and Technical Resources. While Chris is bringing that up, I'm going to queue up another question, and it had to do with automation. So the question was, what about systems users? Is there a way to automatedly download artifacts without an account? So Chris, I'll pose that to you.
Sure. So first of all, let me go ahead and show on the cds.ark.gov page, you can click on CDS Connect to get to the CDS Connect portion. Then you can click on Community. And within the community, we have Technical Resources. And this is where you can find links to the CDS Connect API that Ed was just talking about, the Cql Services tool that we demonstrated, as well as the Smart on FHIR application that I described. Now, regarding the question about being able to download artifacts without an account, so there kind of there's essentially two different components to that. One is for the CDS Connect repository. So the CDS Connect repository currently does not require an account to be able to go and download resources as an individual user. However, if you want to do that in an automated way, if you want to write a script that's going to download things, then you would probably want to use the CDS Connect API that Ed actually described here, which does allow you to access artifacts and to download their CQL representations. For the API, I do believe that you might need an account in order to actually use the API portion, though. We would be happy to set you up with an account to do so, and would invite you to reach out to us for more details if that's something that you're looking for. So there is a Contact Us link up here. If you click on that, that'll provide a form, and you can reach out to us with any questions such as things like that. Now, for the authoring tool itself, there is no automated way to be able to download an artifact from the authoring tool. As I said before, those artifacts are actually protected in, we'll say, like a walled garden for yourself. So you absolutely must log in using your user account in order to be able to access your own artifacts. And right now, we only provide you the opportunity to access them through the web browser and download them that way.
Thanks, Chris. Another question was, what level of mathematical complexity can the authoring tool support? So, for example, long equations for prediction models.
Yeah, so that's a great question. Right now, the authoring tool is focused on building up the kind of queries and criteria that we did in the demonstration. There are other capabilities as well, but being able to do complex mathematical equations is not something yet that we have explored. Now, we do have some ideas around that. The first one is, and this goes for complex mathematical equations or anything else that the CDS authoring tool doesn't support, is that you always have the opportunity to use the CDS authoring tool as the starting point. So perhaps you use that to do 85% of your artifact. And then for that last 15%, maybe you need to download the CQL, and perhaps somebody who's familiar with the CQL specification would then need to modify that CQL to add in, say, a complex mathematical equation. So that's what you could do today. In the future, we are looking at a capability to be able to allow users to upload CQL libraries so that from the authoring tool, they can actually reference them. So in that case, you would still need to write some CQL by hand, but you might write a simple function or something that does the math you need. You would upload it to the authoring tool, and then you would be able to reference it from within the authoring tool. And then the third possibility would be for us to actually provide more user-friendly features for doing things like complex mathematical equations. And that's something we can look at. We haven't quite figured out how we would want that to look, but it is something that certainly we've thought about some and we'd like to consider in the future.
Great, thanks. We got a couple questions. Oh, before I go to the next question, I wanted to mention folks are probably noticing a new poll show up on the WebEx portal. That's our way of asking for your evaluation and feedback around today's webinar. So before you log off today, please go ahead and complete the poll. We had a couple questions around the evidence base to be used for the artifacts. And so how do you tell if the artifacts are evidence-based, or what's the process for appraising or prizing the quality evidence for the artifacts that are on the repository?
Sure. So since I'm driving right now, I'll go ahead and take a whack at this. But Sharon, certainly if you want to say anything, go right ahead. But what I'll say is that within the artifact itself in the repository, we have some certain fields for doing that. So let's go to our familiar artifact here, statin use for the primary prevention of CVD in adults. And here we can see, as we scroll down, that there is a supporting evidence section. Okay, so within this section, we say the source description. There's a link here as well as references. There's some additional information about each one of the recommendations, but if I follow this link, this gives me another page that provides a bit more information about it. and it also provides links to a JAMA article that this is built upon, as well as the USPSTF final recommendation statement that it's built upon. The last thing that I would point out is that in our technical files, we have an implementation guide, as well as the pilot experience and things like that. These are narrative. They're documents that we built. But you can also look at those, and some of those describe the decision-making process that shows specifically how we took that source and how we used that source to create the CQL. So this is one artifact showing that, but all the artifacts have the opportunity to list what their source is, as well as provide links to the source and provide any other supplemental documentation. And we really do want artifacts in the repository to be evidence-based, but we also want that to be very transparent to our users. So we do highly encourage that any artifacts that are uploaded will have information filled out that very clearly identify the sources.
And this is Sharon. I'll add that usually the selection of a topic and the selection of what evidence-based source to use is decided upon by subject matter experts, clinicians, who are within an organization, and sometimes a quality improvement team. Within the CDS Connect project, we definitely look for peer-reviewed journal articles and guidelines that are produced after systematic reviews. The information that is posted in the repository can really convey a lot about that evidence base. One thing that we'll be adding soon to the repository is the opportunity to add disclosures about yourself or the development of the artifact, so that if perhaps an artifact was developed to align with an organization that was maybe sponsored by a drug representative or something like that, viewers would have that context as they're looking at an artifact. But hopefully that provides a little more background on the question.
So this is a couple questions came in around vendor support. So I wonder, Chris, if you could talk about what's your sense of the major EHR vendors, and whether they'll have APIs that can allow providers to import these artifacts into their systems. Can you talk a little bit about that?
Sure. So I brushed upon this a bit during the demonstration, but CQL, as was described earlier, is data model independent. So some CQL might be described against a FHIR data model. Other CQL might be described against another model. In the case of electronic clinical quality measurement, the eCQMs that are developed there are developed against something called the QDM, the quality data model. So what we know is that many vendors are adding support for CQL-based measures, and they're doing that via broader support for CQL in general. But it's important to note that that support is most likely going to be tied, at least in the first implementation, to the quality data model, because that's what's required for those measures. So because a vendor supports CQL for measures doesn't necessarily mean that it would work with clinical decision support to start with. But it does provide a great basis to be able to build on top of that for clinical decision support in the future. We have heard of some vendors that are working on that and have demonstrated FHIR-based CQL support within their products. I don't know that I'm at liberty to share with you which of those vendors that is, because I'm not sure which have made public announcements and which have not. But there are some things happening there. But I think that probably the nearer term solutions really are more likely going to be around things like smart on FHIR applications, where you can take these CQL-based artifacts and integrate them into a Smart on Fire app. Or CDS hooks is something that is also fairly new, but it's actually something that a lot of people are also very excited about and is fairly simple in its design. So we may start to see vendors, formally supporting that in released products in the near to midterm as well. And as I demonstrated today, hopefully there are simple ways that you can integrate CQL with those products as well, even if the vendor itself doesn't have native support for CQL-based CDS. So I can't list off the vendors that have it today because honestly it's still pretty new. It is slightly cutting edge, but it is something that definitely has the attention of the community. CQL is the preferred standard for standards-based logic expression language, and does have the support of the community. EHRs have a lot on their plate, so it's a matter of prioritization and what they choose to do first.
Thanks, Chris. So we are pretty much at the close of our webinar time. I got a couple questions offline, actually, around will we be at HIMSS. So for those of you who are going to be at HIMSS next week, will be the chance to interact with us there. Yes, the short answer is yes. Ark is actually at the Federal Health IT Pavilion on the expo floor, and Cbs Connect is actually part of the interoperability showcase, specifically the bundled payment and chronic pain management use case. So please come visit us at either of those places. So I want to again thank Sharon and Chris. I apologize we didn't get to all the questions, but as I said, we'll answer them in writing and distribute those answers to everyone. Thank you very much for participating in the webinar tonight, and we hope you will join us for future webinars. Thanks very much.